All right, hello everybody, and thank you for joining my talk about LLM chatbot evaluation just before the lunch break. My name is Maria Bader. I'm a senior data scientist at Molly, and since 2023, I've worked on a range of internal and customer-facing AI products. And one of the first products we built was our chatbot, Molly GPT. Now, if I'm really honest with you, in these early days, whenever we went to production with a new feature, this is how it felt like. And it makes a lot of sense. The developments in the field were going extremely fast. There was a lot of pressure to push out exciting, cool new products. And evaluation suites just didn't exist. But a lot of things have changed since then, of course. So everything is fine now. When we push new features, this is more how it feels. And what I want to do now here is share some of these learnings with you, so that you can still push your chatbot features to production fast and efficiently without feeling scared, with having a good feeling in the trust of its performance. So when we talk about chatbot, the base infrastructure is the retriever augmented generation. And of course, now chatbots are much more complex than that. But for the sake of example, the principles that I'm going to talk to, they can be applied to both scenarios, or different scenarios. So for simplicity, we're just going to look at the RAG for now. And there are three kind of flows you can look at when you want to evaluate a system like that. There's the retrieval flow, which checks the quality of the retrieved context from a database. There's the generation step, so how well does the LLM generate an answer based on this retrieved context. And there's a second step. You can also evaluate the response with respect to a ground truth. And ground truth in this context, that can be for specific use cases, like medical use cases or legal use cases. And then lastly, there is the end-to-end flow. So how good is the response actually as answer to the question? We're going to use two tools, the infamous LLM-as-a-judge approach, because it's fast and simple. And because there's more to evaluation than that, look at some modular evaluation suites and metrics. And here I'm going to mostly look at what the package Ragas by Exploding Gradients does. But there are many more packages out there that do evaluation. None of them is really better than the other, and they all kind of overlap in their terminology. But the reason why I'm going to focus a bit on Ragas is just somewhat historical. They were the first around to try to build a unified evaluation framework for this chatbot realm. And they started with a simple LLM-as-a-judge approach, modular ones, and now also, of course, to agentic flows. So if you kind of look at that, you see a broad picture of everything. Now, lastly, we also need an LLM to test. And we're going to use the Catbot, which is a super simple chatbot I built. It's fueled by GPT 4.1. It knows everything about cats based on simple Wikipedia articles. I chunked them based on sections, and then just embedded them into a Chroma database. So let's get started. If this was a classical machine learning use case, we would have a training set to train a model and set a test set aside. And of course, for basically every AI use case, we don't have a test set. We need to synthetically generate that. And there are two ways to do that. The most easy, the fastest one, is to use something called single context generation. So basically, it takes the chunks from your context, plugs them into a prompt, something like, based on this context, generate a question, and then it will reliably return a set of questions for you for each context document. And in many cases, in the first stages of your product, that's already good enough. But if you want it a bit more complex and advanced, you can look at multi-context generation. So what a couple of these evaluation packages like Ragas or Llama Index and DeepEval do is they take your context and plug that into a knowledge graph under the hood. That knowledge graph calculates the connections and the relationships between these documents, and then takes a group of documents and plugs it into the prompt again. Based on these documents, generate some questions. And that can give you much more complex and advanced synthetic questions for your data sets. So then for an example like this, where I have two contexts, one containing some overview information about cats, the other one communication patterns, it can give you a question like this. So how many feral cats are there, and are they as vocal as local pets? And with this, you can kind of have a good start on a synthetic data set. And then how many questions should you actually generate? What is good enough? That really depends on what part of your project you're in right now. So from my experience, somewhere in the prototyping phase, you're always good with around 10 to 50 questions. You can still kind of eyeball the performance, and if things go wrong in the metrics, you can also still understand what is happening, where you need to tune. Once you're in a phase where you're building the prototype of your product or the pilot, anything between 50 and 100 is usually a good rule of thumb. If you're in production and start building new features and want certainty on their performance, I'd say 100 to 1,000 is good. And if you need to benchmark or also look at different kind of edge cases, go above 1,000. That's mostly safe. All right, we have questions. We generated a bunch of them. Now it's time to pass those through your RAG. And then you end up with a data set that looks somewhat like this. So it has your synthetic questions. They will pass through your RAG or your chatbot, whatever. You get for each of these questions a response and your context documents. And then the evaluation flow is usually always the same. So each of these pairs gets an evaluation score, and that is averaged into the final metric. So no surprises here so far. What you can also do, for example, if in your data set you have different kind of sources, some of them are more context groups that are more relevant than others, you can calculate weighted scores. Now, let's get actually started. To keep it light, we're going to start with two very simple concepts that you should also be used to from classical machine learning, and that is context precision and recall. I chose those because at this point they don't even need an LLM to evaluate them, so we kind of stay in a I call it safe realm, because when you have your LLM-as-a-judges, there's also, of course, always some fluctuation in the response of the scores. So staying with those in the start is usually fine. So context precision. So if you think of classical machine learning, precision is the proportion of positive classes among all predictions. So when you translate that into the realm of chatbot evaluation, this translates to the proportion of relevant contexts among all retrieved contexts. So for this example that we just generated, how many feral cats are there, and are they as vocal as local cats, as pet cats? This goes to our database. There are two relevant documents in there, because these are the documents that we actually just used to generate that question. These are the documents that are returned. One of them is relevant, 3 of them are not. So this leads to a context precision of 33%, which is rather low. So how you can interpret this is that context precision kind of tells you how much clutter did your retriever return. Here you see it's quite a lot. And that can be problematic if there's a lot, because that can lead to issues down the line when that goes into the generation step, right? If there's too much irrelevant context, maybe there's some hallucination, maybe irrelevant information is provided in your answer, so you kind of want to avoid that. So a good way to overcome this is, for example, tuning and making the thresholds of your retriever more strict, because then less irrelevant stuff is returned. And then a nice metric to complement this with is the context recall. So again, remember classical machine learning. The recall is the proportion of successfully predicted positive classes among all positive classes. So for the same example that we had before, recall is the proportion of successfully retrieved relevant documents. So here, remember, we had 2 documents, relevant because they were used to generate that question. Only one of them is returned. So we get a context recall of around 50%. So this then tells you how good is your retriever in actually finding the relevant documents. This is, again, not the best score. So in order to improve that, then you can check your chunk sizes, how's the overlap going, maybe switch out your embeddings model, and then slowly improve that score. So for a first start, this is good enough. We can work on building our retrieval performance. Once we're happy with that, we can move to the next step. That's generation. And there are two main metrics that are floating around in this evaluation space around the generation step. And they're called faithfulness and correctness. Faithfulness means you evaluate the response based on the context. And correctness means you evaluate the response based on the ground truth. Let's have a look at an example to understand this subtle difference a bit better. Let's assume I'm asking the chatbot, what sounds do cats make? And the retriever returned a document that says cats bark, which we all know is not true. Ground truth is they meow. Now, let's have a look at this graph here. On the x-axis, we have correctness, and on the y-axis, we have faithfulness. If our chatbot responds with a bark, we know, OK, this scores high on faithfulness because this comes right from the context, but it is actually not correct. It has nothing to do with what is in our ground truth. If the chatbot responds with a meow, this scores high on correctness, but low on faithfulness. If it would respond with a quack, none of these scores are high because it's neither in the context nor in the ground truth. And if you would want it to score high on both, it needs to respond something like, in the context, it says I should bark, but actually I meow. So this means faithfulness is a measure of how well your response is grounded in the context. And usually with chatbots, this is what you want, right? Because you construct this whole retrieval-augmented generation with your database because you want it to have specific kind of knowledge from the database. So it means if the score is low, usually there's stuff in the response that did not come from the context. It could be hallucination or other things it made up. So usually, for these kind of chatbots, this is the main metric you want to have a look at. The thing also with the ground truth is that often you don't have access to that because it can be, well, very expensive to generate this kind of golden data where you know how the answer looks like. Also, your data might change a lot. You usually don't have access to that in my experience. So if that's the case, then you can forget about correctness and only focus on faithfulness. If you have it, so if you have ground truth data, then correctness is a very valuable asset to look at. And we're going to see a bit later why that is. So let's dive a little bit deeper. Let's have a look how faithfulness score is actually calculated. Consider this example. I'm asking the chatbot, what is the Latin name for cat? It returns a context document with that information, and it responds, the Latin name for cat is Felis catus. Now, most LLM-as-a-judge approaches from any kind of evaluation package has a form like this. So it provides a definition of the faithfulness metric. It tells, hey, compare the response to the context and grade it according to some grade or some grading rubric. So for this example, 100% score, everything is good. If we look at the modular approach, they usually consist of two steps. First, they extract statements from the response, and then each of these statements is compared to the context in an individual LLM call and assigned, yes, this comes from the context 1, or it does not come from this context 0, and then it's averaged over these scores. So for our example here, there's one statement it can extract from the response, 100%. So for very simple responses, these are very easy to compare. Let's make it a tiny bit more complex and add a random statement to the response that is not in the context around the plural of Felis yeah, which is Felis. I didn't have Latin in school, so good for me to learn this. So our LLM-as-a-judge approach identifies correctly that half of the statements in the response are actually not in the context. Very nice, score 50%. And then if we do the same with the modular approach, we see 2 statements were extracted. One is from the context, the other one not. Same score of 50%. So you see that as long as your question, answers, responses are rather simple, LLM-as-a-judge is actually pretty good. But you can also imagine that if things grow longer, more complex, we have many different statements, different context documents, a modular approach can give you a much more detailed view of what's going on. When we look at correctness, and with the same example, what changed now is the ground truth. So let's assume everything that's in the answer of the chatbot is also found in the ground truth. So again, LLM-as-a-judge approach, pretty similar to before, a definition, a grading scale, and here we get a 100% score. What these modular approaches now do for correctness is walk the extra mile. So again, we look at the response and the ground truth, and statements are extracted from both. And then these approaches check if the statements of the response are in the ground truth in terms of true positive, false positive, and false negative. So true positive means a statement from the response is also in the ground truth. False positive means that a statement in the response is actually not in the ground truth, so that came from somewhere else. And a false negative is a statement that this is in the ground truth, but it didn't make it into the response. And then based on these, a score called factual similarity, or F1 score, is calculated. And then in some cases, with ground truth, it also makes sense to look at semantic similarity. So maybe the response needs to have a specific format or a list of facts. And then the semantic similarity just calculates the cosine similarity between the response and the ground truth. And both of them are aggregated into a final score. So for this example, you see already that the result is a bit more nuanced. So if you have ground truth, I recommend going with a modular approach because it just gives you more nuance and control of what you care about. All right. Last but not least, is the response actually relevant for the question? And here it depends a lot. If you really want to go with a LLM-as-a-judge approach, what does relevancy mean for you? If you have a good definition what you care about, in terms of relevance, LLM-as-a-judge approach is good. I found that the modular approach here is a bit more neutral and works more reliable. So again, same example. What is the Latin name for cat? And what a modular approach will now do, again, it looks at the response, and now it generates synthetic questions from this response. So in this case, I got 3. What is the Latin name for cat, which is exactly what I actually asked. What does felis catus mean, and what is the plural of felis? So then what will happen? A semantic similarity will be calculated between each question and the original question. Each of them gets a score, and the final score is calculated. So this gives you a good feeling of, well, is the response relevant or not? A limitation I see here is that many of these modular approaches actually only give you the final score, but don't tell you these intermediate steps. So I saw often you end up with a bunch of scores that are either high or low or somewhere in the middle, but you don't really know entirely why and what you need to do exactly to change. So yeah, that's something to consider as well. Either way, we've reached a full circle moment. So we looked at the retriever in terms of recomposition. We looked at the quality of the response in terms of the retrieved context. And we looked at the quality of the response in terms of ground truth. And lastly, we also had a look at the response in terms of the answer relevance. And of course, there's more to chatbots than LLMs. Ragas. So usually what all these packages have are additional suite for different types of evaluation. And they can be basically grouped into 3 categories. So there's something that I call the advanced RAG evaluation. So for example, some of them for the faithfulness metric, so that was response based on the context, they use specific models, in this case an open classifier model that is also built to detect hallucination. So if you need to be extremely sure that there's no hallucination, this might be a nice route to go. There are also different packages that do multimodal RAG evaluation. So that means if your RAG returns images, audio, video, that can be something to check out. And then, of course, there's the whole world of, did your chatbot stay within its role? Did it finish the conversation? And so on. So they exist as well. Then there are general purpose metrics. So you can use them within parts of your chatbot or just to as an inspiration for other LLM applications you want to evaluate. Semantic similarity is kind of the classic. But then, for example, Ragas has also something like the summarization score. So it has a measure for how good did an LLM summarize a specific text. And then, of course, a whole range of NLP metrics is out there as well. And lastly, of course, all these packages also have the agentic suite. And also that's kind of related to MCP servers as well, because they basically work the same. So here they have metrics around the tool call accuracy, around did the tool get called with the right arguments, did the chatbot stay on topic, did it succeed to reach a certain goal. So very similar metrics to what the previous speakers also discussed. And the only limitation I felt there, especially in this agentic frame, is basically that they're all LLM-as-a-judge approaches, where you really need to spend time on preparing your own data set. So you need to, for example, build a data set where you specify for which kind of question, which kind of tool do you want to call. So I personally feel this takes a lot of time, and you don't really always want to do this. So these are a lot of metrics. It can be easy to get overwhelmed by it, especially since naming can also be very difficult between packages. So my last advice is basically sometimes simple is better and faster. So for MollyGPT, we tried a lot of different metrics. We also used our stakeholders as sounding board. And in the end, we always ended up pivoting to the set of metrics that I actually showed, because especially with the ones like recall and precision is something they can relate to. So it made it easier to also bring them on board with these evaluation flows. So don't be afraid to stay simple. Sometimes even LLM-as-a-judge approaches are good enough. And with this, I am done. Thank you for your attention. You can connect with me or with the chatbot. Thank you. And I also shared the slides of this presentation here, so if you want to look it up again, go for it.